Hi students, today we are going to discuss with the topic procedure for the design of Lad-Lead compensation using Bode Plot. Okay, how to design the Lad-Lead compensator in frequency domain. We know that the Lad-Lead compensator improve both the steady state and transient characteristics of the system. For improving the steady state characteristics of the system, the lag compensator will reduce the gain crossover frequency to a now new frequency which is less than the gain crossover frequency of the compensated system, and the lead characteristics can be improved by increasing the bandwidth of the system. Okay, that's the concept of improving the lag and lead. Here we are going to design a Lad-Lead compensator if the if the system, first if we are considering an open loop system, and if the open loop system does not achieve the required parameter, we are going to design a Lad-Lead compensator. Okay, the first step of Lad-Lead compensation is determine the open loop gain K of the uncompensated system to satisfy the specified error requirement. Okay, if we have an open loop system G of us and the steady state gain of K is not specified in the question, we need to find the K by using the specified error requirements given in the system, and we find the value of K in the first step. Next, by considering the K, we are going to draw the Bode plot of the uncompensated system. Okay, next step, we are going to draw the uncompensated system. In the case of uncompensated system, we find the gain crossover frequency, phase crossover frequency, gain margin and phase margin. If the uncompensated system does not satisfy the required specimen, we need to design a compensator. Okay, so we find the gain margin of the system by using the equation, phase margin of the equation, phase margin is equal to 180 plus 5 GC. If both phase margin and gain margin is not achieved the required specification, we need to design a Lad-Lead compensator. Okay, we know that the Lad-Lead compensator is a combination of both lag and lead. So first we design a lag section and then we design a lead section. We know how to design the lag section and how to design the lead section. In the case of Lad-Lead compensator, we are combining both lag and lead compensation technique. Okay, so first we are going to design a lag section. So consider the new phase margin. Okay, we know that the new gain phase margin gamma n equal to gamma d plus epsilon are same as that of lag compensator technique. Gamma n equal to gamma d plus epsilon. This initial phase lag is initially choose as 5 degree. Okay, so gamma d is the desired phase margin or the required specification. Okay, gamma n equal to gamma d plus epsilon. The gamma d is the desired phase margin we need to achieve. So gamma n equal to gamma d plus epsilon. From this equation we got gamma n. That is a step 4. On the next step we have the equation gamma n equals 180 plus 5 GC n. Okay, this 5 GC n equals gamma n minus 180. From step 4 we got the value of gamma n. Okay, substituting the gamma n this here and find the value of 5 GC n. Okay, from the Bode plot we are going to find the gain crossover, new gain crossover frequency corresponding to the 5 GC n. Okay, if in the plot of uncompensated system, the frequency corresponding to 5 GCN is the new gain crossover frequency omega GCN. Okay, in the step 5 we are finding the new gain crossover frequency omega GCN corresponding to 5 GCN. Okay, so in the case of lag compensator we are moving with this omega GCN. Okay, but here we are designing a Lad-Lead compensator. Here the consideration is that the gain crossover frequency, choose a we have a new gain crossover frequency omega GCN. choose a frequency omega GCL somewhat greater than omega GCN. Okay, if for example, if we got phi GCN is equal to minus 135 degree and the corresponding omega GCN is 2.6. Okay, in the case of Lad compensator, we move forward with this 2.6 radian per second frequency, but here we are going to choose a frequency omega GCL, okay, which is somewhat greater than omega GCN. For example, if omega GCN is 2.6, we choose omega GCL as 4. Okay, നമ്മൾ പലരും ചൂസ് ചെയ്യുന്നതിനനുസരിച്ച് അത് മാറിക്കൊണ്ടിരിക്കും. നമുക്ക് എങ്ങനെ വേണമെങ്കിലും ചൂസ് ചെയ്യാം. ഒമേഗ ജി സി എന്നേക്കാളും കൂടിയൊരു ഫ്രീക്വൻസി എന്ത് ചെയ്യണം, ചൂസ് ചെയ്യണമെന്ന് മാത്രമേ ഉള്ളൂ. ഓക്കെ, സോ യു ചൂസ് ഒമേഗ ജി സി എൽ വിച്ച് ഈസ് സംവാട്ട് ഗ്രേറ്റർ ദാൻ ഒമേഗ ജി സി എൻ. So next we need to calculate the beta of the lag compensator. Okay, the beta of the lag compensator, the equation is AGCL is equal to 20 log beta. Okay, in the case of lag compensator, okay, in the case design of lag compensator design, we have AGCN. We are finding the gain corresponding to the gain omega GCN. Okay, but here we are considering the frequencies omega GCL. So here the gain becomes AGCL. AGCL is equal to 20 log beta, and beta is equal to 10 raised to AGCL by 20. Okay, beta is equal to 10 raised to AGCL by 20. This AGCL can be obtained from the Bode plot. Omega GCL ne corresponding ആയിട്ടുള്ള AGCL gain ഏത് പ്ലോട്ട്, മാഗ്നിറ്റ്യൂഡ് പ്ലോട്ടിൽ നമ്മൾ എന്ത് ചെയ്യും, ഫൈൻഡ് ഔട്ട് ചെയ്യും. ദാറ്റ് വാല്യൂ ഇസ് AGCL. So AGCL is equal to 20 log beta, therefore beta is equal to anti-log AGCL by 20 or 10 raised to AGCL by 20. Okay, next we got the value of beta. Next we need to find the transfer, we need to find the time constant T1. Okay, we know that the zero of the lag compensator is placed 1 by 10th position of new gain crossover frequency. Here we are considering the frequencies omega GCL. So 0 is equal to 1 by T1. It is 1 by T. We have lag section and lead section. So lag section time constant is C1. Okay, T1. So ZC1 is equal to 1 by T1. That is equal to omega GCL by 10. By comparing these equations, we got T1 is equal to 10 by omega GCL. Okay, T1 is equal to 10 by omega GCL. So from this step 6 we got beta, and step 7 we got T1. So next we move to the transfer function of the lag compensator. So lag transfer function of the lag section is G1 of S. That G1 of S equals S plus 1 by T1 divided by S plus 1 by beta T1. That is equal to beta into 1 plus S T1 divided by 1 plus S beta T1. Okay, so here complete the designing of lag section. Okay, lags, we have both lag compensator and lead compensator. First we design the lag section, next we are going to design the lead section. The transfer function of lead section is S plus 1 by T2 divided by S plus 1 by alpha T2. Okay, the lead compensator transfer function is S plus 1 by T2 divided by S plus 1 by alpha T2. So we need to find both T2 and alpha. Okay, if we are designing a lead compensator, we are finding alpha by the equation alpha is equal to 1 minus sin phi m divided by 1 plus sin phi m. But in the case of Lad-Lead compensator, we are finding alpha by the equation alpha equal to 1 by beta. We already discussed that in the case of Lad compensator, alpha into beta equal to 1. That is the condition. Alpha into beta equal to 1 is the condition of a Lad-Lead compensator. From the lag section we got the value of beta. So alpha can be found out by using the equation alpha is equal to 1 by beta. So in the lead section alpha equal to 1 by beta. Okay, so we got the value of beta. Next we need to find the maximum frequency omega m. Okay, so omega m is find out by, from the Bode plot, find omega m, which is the frequency as with dB gain is minus 20 log 1 by root alpha. So find the gain minus 20 log 1 by root alpha and find the frequency corresponding to that gain. Okay, From the Bode plot, find omega m corresponding to the gain minus 20 log 1 by root alpha. So we got the value of omega m. This we know the equation of omega m is 1 by t root alpha. So T2 is equal to 1 by omega m root alpha. Okay, from the equation we got T2. T2 is equal to 1 by omega m root alpha. This omega m is find out by using this gain equation. The gain equation is minus 20 log 1 by root alpha. From the magnitude plot, find the frequency corresponding to this gain. Okay, so T2 is equal to 1 by omega m root alpha. So therefore the transfer function, we got the value of both. We got the transfer function of lag section and the lead section is G2 of S. So G2 of S equals alpha into 1 plus S T2 divided by 1 plus S alpha T2. Okay, G2 of S equals alpha into 1 plus S T2 divided by 1 plus S alpha T2. So we got the transfer function of lag section and lead section. So next we need to find the transfer function of Lad-Lead Compensator. We got the transfer function of lag section and lead section. Therefore the transfer function of the Lad-Lead Compensator, GC of S equals G1 of S into G2 of S. Okay, G1 of S into G2 of S. That is G1 of S equal to beta into 1 plus S T1 divided by 1 plus S beta T1 into G2 of S equals alpha into 1 plus S T2 divided by 1 plus S alpha T2. So for the transfer function GC of S equals, we know that this alpha into beta equal to 1. Alpha into beta 1 എന്നുള്ള condition ആണ് നമ്മൾ എന്ത് കണ്ടുപിടിച്ചത്? Alpha കണ്ടുപിടിച്ചത്. That is alpha equal to 1 by beta. So we can write alpha into beta equal to 1. അപ്പോൾ ഇത് രണ്ടും കൂടെ ചേർന്ന് എന്തായി മാറും? It becomes alpha into beta be equal to 1. അല്ലേ? Alpha into beta എത്രയായിട്ടാണ് കിട്ടുന്നത്? 1 ആയിട്ട് നമുക്ക് കിട്ടും. So GC of S equals എന്തായിരിക്കും? 1 plus S T1 divided by 1 plus S beta T1 into 1 plus S T2 divided by 1 plus S alpha T2. That is the transfer function of the Lad-Lead compensator. Next we need to find the transfer function of the compensated system. So transfer function of the compensated system is GC of S into G of S. Okay. Yes, that is transfer open loop transfer function of the compensated system. G naught of S equals GC of S into G of S. GC of S is transfer function of the compensator into G of S. നമുക്കൊരു attenuation constant കൊണ്ട് multiply ചെയ്യേണ്ട ആവശ്യമില്ല. എന്തുകൊണ്ടാണ്? This alpha into beta be equal to 1. അപ്പോൾ അവിടെ cancel ചെയ്യാനൊന്നും ഉണ്ടാവില്ല. So G naught of S equals GC of S into G of S. Okay. So open loop transfer function of the compensated system, G naught of S equals GC of S into G of S. So here we have got the transfer function of the compensated system, G naught of S. Next we need to find the phase margin of the compensated system. Okay, the phase margin of the compensated system is gamma naught equals 180 plus 5GC naught. Okay, the equation is gamma naught equals 180 plus 5GC naught. Right, gamma naught equals 180 plus 5GC naught is the equation. So from this G naught of S, write the equation of 5GC naught. The 5GC naught is the angle, phase angle. Okay, write the equation for the angle. Okay, from this G naught of S, we can write the equation of 5GC naught. From this 5GC naught, we have an unknown of omega GC. We have a frequency omega, that frequency is unknown, and we designed this compensator for a frequency omega GCL. Okay, at 5, write the equation of 5GC naught and substitute the omega as in omega GC naught, the equation as omega GCL. Okay, the equation omega GCL. Okay, omega GCL. We have designed the system for a gain corpus of frequency omega GCL. In the lag compensator, we have designed omega GCN, but here we choose a frequency somewhat greater than omega GCN. So at 5GC naught, 5GC naught എന്ത് ചെയ്യുക കണ്ടുപിടിക്കുക ആംഗിൾഡ് ഇക്വേഷൻ ഈ ജി നോട്ട് ഓഫ് എസിൻ്റെ ആംഗിൾഡ് ഇക്വേഷൻ നമുക്ക് എന്ത് കിട്ടും 5GC naught കിട്ടും 5GC naught അൺനോൺ എന്ന് പറയുന്നത് എന്താണ് ഒമേഗയാണ് ആ ഒമേഗ നമുക്കറിയാം നമ്മൾ ഡിസൈൻ ചെയ്തിരിക്കുന്നത് എന്താണ് ഒമേഗ GCL നാണ് സോ സബ്സ്റ്റിറ്റ്യൂട്ട് ദാറ്റ് ഒമേഗ GCL ഹിയർ അപ്പം നമുക്ക് എന്ത് കിട്ടും 5GC naught കിട്ടും therefore ഗാമ നോട്ട് ഈക്വൽ ടു 180 പ്ലസ് 5GC naught and check where the desired phase margin is achieved or not. Question തന്നിരിക്കുന്ന desired phase margin എന്ത് ചെയ്യണം അച്ചീവ് ചെയ്തിട്ടുണ്ടോ ഇല്ലയോ എന്ന് എന്ത് ചെയ്യണം ചെക്ക് ചെയ്യണം. If the specifications are not satisfied, specifications satisfy ചെയ്തിട്ടില്ല എന്നുണ്ടെങ്കിൽ choose another choice of alpha such that alpha less than 1 by beta. Okay, നമ്മൾ ഓൾറെഡി ബീറ്റ വരെ ചെയ്തിട്ടുണ്ട് അതിന് എന്ത് ചെയ്യേണ്ട ലാഗ് സെക്ഷൻ മാറ്റണ്ട ലീഡ് സെക്ഷൻ എന്ത് ചെയ്യണം ചേഞ്ച് ചെയ്യണം ബൈ ചൂസിങ് അനദർ വാല്യൂ ഫോർ ആൽഫ. അപ്പോൾ സ്റ്റെപ്പ് 8 തൊട്ട് 11 വരെ പിന്നെ എന്ത് ചെയ്യുക റിപ്പീറ്റ് ചെയ്യുക അതായത് ആൽഫയുടെ വാല്യൂ എന്ത് ചെയ്യുക ആൽഫ ലെസ് ദാൻ ബീറ്റ എന്നാണ് കണ്ടീഷൻ. നമ്മൾ ചൂസ് ചെയ്തിരിക്കുന്ന ആൽഫയെക്കാളും ചെറിയൊരു വാല്യൂ ഓഫ് ആൽഫ എന്ത് ചെയ്യുക ചൂസ് ചെയ്യുക then repeat the step from step 8 to step 11 if the desired phase margin is not achieved. Okay, that is the design procedure of Lad-Lead Compensator. So Lad-Lead Compensator is a combination of lag section and lead compensator. So first we are designing the lag section and next we are designing the lead section and we are checking whether required specification is achieved or not. There is no need to draw the Bode plot of the compensated system. എന്തിനാ Bode plot വരച്ച് compensated systemത്തിൻ്റെ Bode plot വരച്ചിട്ട് 5GC naught കണ്ടുപിടിക്കണമെന്ന് നിർബന്ധമില്ല. അതുകൊണ്ടാണ് നമ്മൾ 5GC naughtiൻ്റെ ഇക്വേഷനിൽ ഒമേഗ GCLൻ്റെ വാല്യൂ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്തിട്ടായാലും എന്ത് ചെയ്താൽ മതി ചെക്ക് ചെയ്താൽ മതി. ഓക്കെ, ദാറ്റ് ഈസ് ദ procedure of the designing of Lad-Lead compensator in frequency domain. Okay, thank you.